All right, number 38. In some ways, it's a little bit tedious, but in other ways, this is a really valuable problem to do, which is why I like it so much. Um, all right, uh, five. This table gives us four sets of data. So we've got four sets of data here, um, and this illustrates the dangers of calculating without plotting your data. Okay, so without making scatter plots, we want to find the correlation and the least squares regression line for all four data sets. What do you notice? Use a regression line to predict y for x equals 10. Okay, so what I went ahead and did ahead of time, and what you should do right now, or before you do the problem, is I put the data in all the lists. Okay, um, okay, that way I've got, you can see here, if I look at my list, I did, L1, I put, it there, and I wrote it on the side here. So I've got L1 and L3 for the first data set, L1 and L4 for the second, 5 and 2, and so forth. That way I can just call up the different lists when I do it, so I'm not punching in the data each and every time for every list, or for every problem. So if I want to find this, first of all, does that make sense? So for example, I want to do the regression line for the first data set. I just come down here and I go L1 and L3 because I know that's where the data is. If I want to do the second one, I'm going to do L1 and L4 rather than keep going back and putting the data in every single time. Okay, so calculate. So I've got for this first data set, oops, I'm going to push this over here. I've got, and I wrote it y equals 0.5 plus 3x, and r is 0.81. Y hat equals 0.5 plus 3x, and we got r is equal to 0.81, and it said predict y when x is 10. So when x equals 10, y hat is 30.5 approximately. Okay, does that make sense? Alright, so for the second one, we got L1 and L4. So I'm going to go to I'm going to clear that screen because it's going to get all messy. Otherwise, calc. I'm going to do L1 and L4. Second L4. .5 and 3. Okay, so I go y hat 0.5 plus 3x, and in this case r was 0.81, and when x is 10, of course y hat will be the same. Okay, I think you might be onto a pattern here. Let's look at L1 and L5 for the third data set. Okay, so let's clear that screen and do stat calc, and we got L1 versus L5. Down to calculate. Okay, A is 0.499, so I'm going to round that to 0.5 and 3. And I didn't catch R on that one, 0.81. So when x is 10, y hat is 30.5 approximately. And gee, Wally, what do you think this is going to be? L2 and L6? Let's look at that. Oops. L2, L6. .5, 3, 0.81. Now, do you think these guys all look the same, the scatter plots? That's the purpose of this, because according to this data, man, the regression lines are all the same, R values all the same, and your predictions are all the same. It says make a scatter plot of each. Well, I already did that, and I put them down here for you. Although, let me just give you a refresher. To do the scatter plot, remember it's second stat plot on, and let's do L1 versus L3. Here is second L1. I'm going to show you something on here. Second L3. Okay, and if you go to zoom, well, actually quit this screen, second quit, and if you go to zoom and then go down to zoom stat, okay, it'll take the data in your stat lists and give you a scatter plot for it. So you can see that the regression line is going to go right through the middle of that data, and it's going to be about what that line is right there. Okay, so zoom stat is a good way to look at the scatter plot without having to pick the windows and so forth. So I went ahead and graphed all these. Okay, this is data set, we'll call them A, B, C, and D. Okay, so here's plot A, which we just did. Okay, here's plot B. Interesting, the regression line is exactly the same. Goes about like that. Now the problem is, well, let me ask you this. Why is that a problem? I mean, what is the big deal? Well, the problem is the regression line in R only makes sense when the data is linear. So that's why we can have this up here, R equal 0.81, be the same, but it doesn't make any sense because the data is not linear. Okay, let's look at what is R3. R3, or plot C, I should say. Plot C takes, this data is a straight line, but because of this outlier up here, it actually takes my line and pulls it up this way, called an influential outlier, pulls it up like that, and so this line really doesn't model the data very well. Okay, so an outlier affects it in part, and graph D has all of my data stacked here except that one, so all the data is really chunked here except this one outlier makes my line look like that. Same equation, y hat equals, what was it, 0.5 plus 3x, and it all has the same correlation. And of course, for, make these smaller here, for this one, and this one, none of the predictions are terrible. I mean, you can't use the line to predict data because when it's 10, these are awful predictions, right? Okay, it's only valid for this guy right here, of course. So, purpose of the problem? Always plot your data. Does that make sense? All right, there you have it.